Good morning, everybody. Now that you know about the series, the sequences of arithmetic and geometrical sequences, let's look at what happens if we add all those terms of the sequences. The first one that we're going to look at is the sum of an arithmetic series. Now, what's the difference between a sequence and a series? A sequence has terms with semicolons between them. A series has terms with pluses between them. So, if we need to calculate the sum of the terms, we talk about a series. Let's look at an arithmetic sequence. It's 2, 4, and 6. The constant difference is 2 because we constantly add a constant of 2 to get the next term. Now, if we want to calculate the sum of all these terms of an arithmetic sequence, we can write it as Sn, or the sum of n terms. An alternative method of writing is to use the sigma notation. We will start with k is 1, term 1, until k is n, term n. We will look at this notation in another lesson. So for now, we're just going to look at the sum of n terms, and we have two formulas. The first formula is where we know the first term and where we know the last term. Then it's the number of terms divided by 2 multiplied by the first term plus the last term. If we don't know the last term's value, the formula looks like this. It's the number of terms divided by 2 multiplied by 2a plus n minus 1d. Now you unfortunately have to know the proofs of both of these formulas. So let's quickly go through it. The proof of the first sum formula, you have to know and you have to learn this. It's on your notes on page 3. If we write out the terms, the first term will be a, and because it's an arithmetic sequence or arithmetic series, we add d to a to get the second term. And to get the third term, we add another d, so we add two d's, etc., etc., etc. If we end at the last term and we want the previous term, we subtract d. If you want the term before that, you subtract another d, so we subtract two d's. This will be my first equation. Now to get the second equation, I simply rewrite this equation but from back to front. So I start with the last term, then with the second last term, then with the one before that, and I end with our first term, the one after that, and the one after that. So I simply swapped this equation to this one, and this is my second equation. Now to get to the sum formula, we simply add all these terms. So Sn plus Sn gives you 2Sn. A plus L is A plus L. A plus D plus L minus D gives me A plus L because the D's cancel out. The same here, the two D's cancel out and you get A plus L up until the end of the row. So what we actually have here is 2Sn and n times, because we have n terms, n times A plus L. I want the sum alone, so I divide by 2 on both sides. And here we get our first formula. So if I want you to prove this formula, you end here. If they want you to prove the long formula, you must carry on. Now, the last term is also known as term n. And we know that term n has a formula. So we substitute Tn with a plus n minus 1d. And then if we add those two a's, we get 2a. And this is the proof for the long formula for the arithmetic series. Again, you have to learn this and you have to know this for all the tests and all the exams. Now quickly let's look at some examples. Determine the sum of the first three terms of this sequence. It's a sequence because we have semicolons. Now we know that the sum of an arithmetic sequence is n over 2 times 2a plus n minus 1 times d. A will be negative 2, d will be minus 4 minus 2 gives me negative 2. Minus 6 minus 4 gives me negative 2. So this will be my d. And now I can substitute the a and the d. We want the first three terms, so n will be 3. The sum of three terms will be 3 divided by 2 times 2 times a plus n is 3 minus 1, d is negative 2. If you type that into your calculator, you will see that the sum of the first three terms will be negative 12. Okay, I used this simple sum just to show you that this formula works. If we add these three terms, we will also get negative 12. Let's look at another example where we make the terms more than 3. Calculate the sum to 30 terms. So this is my n. The 3 is my a. I need to work out the d. 5 minus 3 is 2. 7 minus 5 is 2. So my d is 2. We know that it's an arithmetic sequence or series. So the sum of n terms will be n over 2 times 2a plus n minus 1 times d. You always start a sum with the formula. Then we substitute. The sum of 30 terms is 30 over 2, 2 times 3 plus 30 minus 1 times d. So the sum of 30 terms will be 960. So if you add all the values of 30 terms, you'll get 960. Our third example, we must calculate the sum up until the last term. Okay, this is a. I don't know what n is, but I can work out the d. 13 minus 8 is 5. 18 minus 13 is 5. So d is 5. This is definitely an arithmetic series because we have a constant difference. First, to calculate the sum of n terms, we write our formula. It's 2a plus n minus 1 times d. We don't know what n is, so we have to work out n. This is term n, the last term of the series. So Tn will be a plus n minus 1 times d. We know a is 8. We don't know what n is, but we know d is 5. We also know that term n has a value of 253. So now we can calculate n. 253 equals 8. 5 times n is 5n minus 5. So 5n, 8 minus 5 is 3. Take the 3 over to the left hand side, then we minus it, so it's 250 equals 5n. Now we divide by 5 and we get n equals 50. So n is 50 and we can substitute the 50 into our sum formula. The sum of 50 terms is 50 divided by 2 times 2a is 8 plus 50 minus 1 is 49, d is 5. So the sum of 50 terms, if you calculate that, will be 6,525. That means that if we add all 50 terms, we get this as an answer. And we know that we have 50 terms because we calculated n. In example number 4, we ask you how many terms, in other words, we want n, of this series will add up to this. So this is my Sn. We start with determining what d is. A is 5, d is 4. I know Sn has a value and I need to calculate n. So we always start with the formula n over 2, 2a plus n minus 1 times d. Sn is 1652. I don't know what n is, so I keep it n. 2 times a is 2 times 5 plus n minus 1 and d has a value of 4. 1652 equals n over 2, 10 plus 4n minus 4. I simply multiplied the bracket. Now I have 1652 equals n over 2, 4n plus 6. I'm going to multiply with 2, or you can multiply with n and divide by 2. So let's do that one. 4n times n is 4n squared, divide by 2, plus 6 times n is 6n, divide by 2. And now you can divide 2 goes into itself once and into 4 2 times. 2 goes into itself once and into 6 3 times. And we have 1652 equals 2n squared plus 3n. This looks a lot like a trinomial. So let's make it one. 2n squared plus 3n minus 1652. And now I need to get my factors. If you fact 1652 and you play a little with the factors, you will see that it will end up with 59 times 28. So n will be negative 59 over 2, or n will be 28. We can't have a negative position in our sequence, so this is not applicable. My answer is only 28. I wanted to know how many terms will add up to 1652. Answer the question. Therefore, 28 terms will add up to 1652. Let's look at another example. Here we have 5 plus 3 plus 7 plus 3 plus 9 plus 3 up until 59. Can you see that this plus 3 repeats itself within this series? So we're going to split this series into two series. The one with all the odd numbers, 5 plus 7 plus 9 plus 59, and all the threes, 3 plus 3 plus 3 plus our last 3. Okay, in this series, my A is 5, my D is 2, and I don't know what n is. So I first need to work out the n there before I can calculate the number or the sum of the series. We know this is term n, so Tn equals A plus n minus 1 times D. Tn has a value of 59, A is 5, n minus 1 and D is 2. If you work this out, you will get that n is 28. So I know that n is 28 in the first series. So let's calculate the sum of the first half. So it's n over 2, 2a plus n minus 1 times d. We want the sum of 28 terms. That's 28 over 2. 2 times 5 plus 28 minus 1 is 27. And d has a value of 2. So the sum of the 28 odd numbers is 896. If we have 28 odd numbers and the threes end just before that, how many threes will we have? 27. And the sum of all the threes will be 27 threes, and that will be 81. So this means that the sum of the first odd terms is 896, and the sum of all the threes is 81. So the sum of 27 plus 28 is 55 terms, will be the 896 plus the 81, and that gives you 977.